Today, I'm going to show you how to measure current without blowing up the current meter. My assistant today is Danny, who has come the closest that anyone has ever come to blowing up a current meter without actually doing it. So she's going to try not to blow it up this time.
I'll try not to.
Try not to. Okay. So, here we have our voltmeter, or multimeter. Standard voltmeter. Now, can you tell me what's wrong with what we're trying to do so far and why this won't work for measuring current?
Because
Well, the first thing that you missed already is that you have to turn it on. That's important. Alright, now what else is wrong?
What else is wrong? Well, shouldn't it be over here?
Which one, the yellow or the white?
First the yellow to make sure.
First the yellow, right. Which one, the black or the red?
Red.
Okay. Okay. What if we took the black one?
It would blow it up? Maybe?
It might. I don't know what it would do. It won't work, that's for sure. So what we're going to do is we're going to put, now it's still not going to work. Why?
Because you're on 20 milli.
I'm not on anything right now.
Oh, you're not on anything.
I'm on 200 kilo ohms. See, look up there.
You want it down here.
You want it down there on the 20 amps. The idea here is you want to check to make sure that you're not going to blow anything up before you do anything else. Now, if we take a look at our circuit here, okay, the next thing we want to do, and we haven't even taken any measurements yet, is we want to look at this and see, does this make sense? Because if it doesn't make sense, we're probably going to blow something up. So what do you look at?
You look at the where you're measuring current, so you want to make sure that this isn't above 20, right?
Well, we want to make sure it's below 0.2.
0.2.
Because we're going to move it over to 0.2 and just the 200 milliamps in just a minute. If that's above 0.2,
You'll blow it up.
you'll blow it up. All right, that's one way to blow it up. So now we have our circuit here, and what we have is a 100 ohm and 47 ohm resistor in parallel. Now, we're going to measure the current through the 100 ohm resistor, which is this one here. How do we do it, Danny?
You hook one here.
No! That's how you blow up the meter. You have to do what?
Remove the blue.
Not necessarily blue, but you know, in this case it is blue.
Move a wire.
Remove a wire. You have to break the circuit. And she did that on purpose, by the way. She knows better.
By now.
All right? Now, if you notice, the current has dropped. Why? Because there's no current going through that 100 ohm resistor. And then what do we do?
You plug the red one in here, and then the black one in there.
All right, let's see what happens. Just kidding. Yes, that is correct. All right, now if we see here, we have 0.03 amps on our current meter, which means, and this is going back to 0.09, up by about 0.03. All this makes sense. We're doing good. Christian, your finger is in front of the lens again.
It doesn't show up.
He wanted to get into movies.
Finger famous.
All right, so now what do?
We move the red over to the white and change this to 200 milliamps.
Why do we do that?
More accurate reading.
Exactly, more accurate reading. If we look at it right now, it says 0.07 amps. Is that right? No, because I haven't moved it over yet. And it says 28.6. 28.6 amps. Milliamps. That's important. When you moved it over to milliamps. That's all right. So now we are done. That's measuring the current through the 100 ohm resistor. How do you know it's through the 100 ohm resistor?
Because it's connected to it.
Well, that's the only path the electricity could take to go through the 100 ohm and only the 100 ohm resistor. So if we take our current meter back out and put the blue wire back in, restoring the circuit, okay? If we wanted to measure the current through the 47 ohm resistor, which wire would we have to remove and replace with our current meter?
Would remove this one.
That would work. This one also would work.
Oh yeah, that's right.
Okay, so sometimes there's more than one answer. Now, what if we wanted to measure the current going through the whole circuit? Which wire would we remove then?
I want to say this one, not
Which one? The blue one?
the blue one.
Now that one only goes through the 100 ohm. Because electricity goes. You want something before it splits off or after it comes back together.
At the end over here.
Yes, and that, coincidentally, we have another blue wire. All right. Now, what happens here is this is where the current from the two resistors comes back together. All right. So if we take this out here and take the blue wire out without hurting ourselves this time, and now we should go back through and do it on the yellow again. We're not going to, just because, you've seen it already. Watch it again if you didn't get it. Now go ahead and connect it without hurting yourself, and we'll see if this goes up. What do you think it's going to come out to be about?
0.9, whatever you have to.
Well, 0.09. Actually, it drifted down to 0.08. And if you see here, it comes out to 82.5 milliamps. So that makes sense, doesn't it?
Yep.
All right, because here we're measuring the whole current, so it should match what that says. This is more accurate. That's why we use it. If this was accurate, we wouldn't have to. Also, this we can measure inside the circuit. We can't do that with this guy here. All right. So the important thing to remember is, 1, check this to make sure it's below 0.2. 2, measure it first on the yellow, the 20 amp max. Make sure you're below 0.2 amps. 3, this should really be 1.5 now that I think about it. You have to remove a wire or somehow break the circuit for you to make a current measurement. If when you take out a wire, this current doesn't go down at all, you're going to blow something up. See, because watch what happens. I take this out, it drops down to 0.06. I take this one out, it drops down to 0.03. All right? We're replacing the wire with our current meter. If you connect the current meter across a resistor, you're going to blow it, because what you've done is you've created a path with zero resistance. And any voltage, current is equal to voltage divided by resistance. Resistance is 0, current goes to infinite, and this is just a little multimeter. It can't handle infinite current. All right? Thank you for your assistance, and I'll see you in the physics lab.